This is a common data question given in EC 2009 for 4 marks. It consists of two sub-questions, question 1 and question 2. A circuit is given. Let's read the question. Consider the CMOS circuit shown where the gate voltage Vg of the Mosfet is increased from 0, while the gate voltage of the PMOS transistor is kept constant at 3 volts. Assume that for both transistors, the magnitude of the threshold voltage is 1 volt and the product of the transconductance parameter and the W by L ratio, that is the quantity mu Cox W by L, is 1 milliampere per volt square. So this is the data given and the circuit shown. Let's see the first question. For small increase in Vg beyond 1 volt, which of the following gives the correct description of the region of operation of each MOSFET? So we have two transistors and we are supposed to find which transistor is in what region. So let me take, this is M1 and this is M2. Threshold voltage is given as 1 volt. Vg is having a voltage of 1 volt plus a small increase, which means let me write this as 1 plus volt, which is slightly higher than 1 volt. To understand what happens when we increase Vg slightly higher than Vt, let's see what happens when Vg is equal to 1 volt. When Vg is equal to 1 volt, obviously M1 is in cutoff. There won't be any current flowing through the MOSFET. In that case, we know the PMOS transistor has a VGS which is greater than Vt. Magnitude of VGS is 2 volts for PMOS, which is greater than magnitude of Vt 1 volt. Hence, PMOS has a channel created and there is no current flowing, which means the voltage drop across the channel is 0. Hence, V0 will be equal to 5 volts. So when Vg is equal to 1 volt, V0 will be equal to 5 volts. When V0 is equal to 5 volts, VDS of PMOS is 0, which means the PMOS transistor is in linear region and M1 transistor was in cutoff region. Now if we make Vg slightly higher than 1 volt, it's not going to change things drastically, but of course there will be some current flowing now, due to which MOS transistor M2 is not going to change the region of operation by a high value because the current is small. Voltage drop across M2 will be still small. So hence V0 will be slightly less compared to 5 volts, slightly 5 minus volt, which means M1 across Vd is going to be very high voltage and VGS value is slightly greater than 1 volt, which means M1 will be in saturation region. Obviously M2 VDS is very small, hence M2 will be in linear region. Hence we can say the correct option is NMOS transistor in saturation and PMOS transistor in triode region, which is linear region. Option D is the correct answer for question 1. Now let's look at question 2. Question 2 is estimate the output voltage V0 for Vg is equal to 1.5 volts. Previously we have taken in question 1 Vg is 1 plus volt. So here we are taking Vg is equal to 1.5 volt. Now which region of operation the transistors are in? That is still a question, hence a hint is given here. Use the approximate current voltage equation for each MOSFET based on the answer to above question. In above question we have taken NMOS in saturation, PMOS in triode. So if you take the same current equations, we are going to get the output voltage now. So let's equate the current, because current flowing through PMOS should be equal to current flowing through NMOS. So magnitude of IDP should be equal to IDN. Now as PMOS is in linear region, we'll take mu Cox W by L of PMOS transistor times VGSP minus Vt times magnitude of VDS minus VDS magnitude square over 2 should be equal to IDN, which is mu Cox W by L of N times VGS minus Vt whole square divided by 2. As we are given in the question that mu Cox W by L of both the transistors are same, hence cancel. VGSP magnitude is 2 volts minus Vt magnitude is 1 volt, which is 2 minus 1, 1 volt times magnitude of VDS for PMOS is 5 minus V naught minus 5 minus V naught whole square divided by 2 is equal to VGS of NMOS is 1.5 given, minus 1 is 0.5 whole square, which is 1 by 4, times 1 by 2 is 1 over 8. Let's take 5 minus V naught as a variable x. We can write 4x square minus 8x plus 1 is equal to 0. We can write x is equal to 8 plus or minus square root of 64 minus 16 divided by 2a, which is 8, is equal to 1 plus or minus square root of 3 times 4 divided by 8, which is equal to 1 plus or minus square root 3 by 2. Of course, x is equal to 5 minus V naught. 5 minus V naught is equal to 1 plus or minus square root of 3 by 2. So we can write V naught is equal to 4 plus or minus square root 3 by 2. Now we have to choose which one is correct. Is it 4 plus square root 3 by 2 or 4 minus square root 3 by 2? We assumed that PMOS transistor is in linear region. If PMOS transistor has to be in linear region, obviously the magnitude of VDS of P should be less than VGS minus VT, which is magnitude of VGS P minus VT. So VDS P magnitude should be less than 2 minus 1, which means VDS P magnitude should be less than 1. If it has to be less than 1, which means V naught should be greater than 4 volts, which clears our confusion that V naught should be greater than 4 volts. Only then the assumption of M2 being in linear region is correct. So the correct answer is 4 plus square root 3 by 2. So the correct option is option D.